Okay, this is an example of, well, first of all, how to find the line of best fit using linear regression, but also how to use Excel to help you to draw scatter plots and to determine that line of best fit. All of this could be done with pen and paper, but using Excel just makes it a little bit easier. I've already prepared this Excel sheet by typing in the values for X and Y. You'll see that there's a column for X and there's a column for Y, and I'll put little titles at the top. The formula that we need to use are this formula here for the gradient, and the formula below it is for the intercept. The intercept C depends on the gradient M, so we have to work out the gradient M first of all. One good thing that we can do before we start is we can actually draw a scatter plot of the data and see if that can help us just to see whether a line of best fit is suitable. So what I've done is I've highlighted the data set and I've gone to insert and then scatter, and I've just inserted a scatter plot. I'll just move that over so we can see it on the screen. Make it a little bit smaller, and we don't need the series, so I'll get rid of that. And you'll see that there's more or less a straight line fit there. There's one point which looks slightly odd. If that one was ignored, we'd have a much better line of straight line fit. So it looks okay at the moment. Next step, have a look at the formula. We need the sum of the x's, the sum of the y's, the sum of x times y, and the sum of x squared. So what we need is a column for x squared and a column for xy. And in this column we're going to put in there equals that cell multiplied by that cell again, so B2 star B2. And if we copy that formula down by just clicking on that bottom corner and dragging, then we've worked out x squared for each point. To work out xy, we press equals and then click on the x term, press multiply, click on the y term, which is 1200 for that first point, and if we drag down we get the other points. But it's really the sums that we want of these, so I'm just going to type sum and then put equals sum open brackets and then choose the range of values above. So the sum of the x is 120. If I click on that cell and drag it across, then I get the sum of the other four columns, sums of the other four columns. So that means that now I can work out the gradient M is equal to, so I'll just put a little M there, equals, let's put it just over a little bit, sorry, should have done that before. M equals, what is it? It's the equals open brackets, the sum of the x's, which is that cell, times the sum of the y's, minus 10, which is n, times the sum of the xy's, which is that, E13, close brackets, divided by, and then we have the sum of x all squared. So that means divided by open brackets B13 times B13, that's the sum of x times the sum of x, minus 10 times the sum of the x squared terms, which is that final cell there. Now if we just press return, we get 2.122 for the gradient. The intercept is then given by, again using the numbers that we've already calculated, we can calculate that as equals the sum of y's, which is 400, divided by n, which is 10, minus the gradient, which we calculated in the cell above, H12, multiplied by the sum of the x's, divided by 10. If we do that, we get 14.53521. So we've got the slope and the intercept of the best fit straight line. Now, as an aside, there are two other ways of doing that in Excel. That's the way that we've done it, is using the formula as the formula was given. But there is an inbuilt formula, called intercept. So we can use that. If we do equals intercept, open brackets, we have to put the y's in first. So I choose the C2 to C11, comma, and then we put the x's in. If we close brackets and press, we get the intercept directly. So we don't need to put the formula in. And the slope is equal to, surprise, surprise, there's a formula called slope, and we put the y's in, comma, and the x's, and that should give us exactly the same value as before. So it doesn't matter how you do that. If you do it with pen and paper, then the marker will be looking for some method marks, so we want to see the table and make sure you've calculated the sums. There is another way as well. If we go to our scatter diagram at the bottom, if you click on one of the points, right click and click on add trend line, we get this table here. We can add a linear trend line, so make sure linear's being ticked, and down at the bottom there it says display equation on chart, and if we press close, then there is the trend line, the best fit line, and you can probably just see it there. It says y equals 2.1221x plus 14.535, exactly the same result again.